All right, my friend, we start today with another chapter, and look at that. We have a lot of exercises this time. I immediately noticed that we have string copy, string n copy, and here we have string l copy. These are all very similar functions, so we're gonna make this video with all of these. So you can really appreciate, you can really understand what is going on with these functions. So online, I stumbled upon this very good article that I suggest you to read. I will link in the description, which is the ups and downs of strlcpy. Let's read a little bit this article together. So basically what do we have? Once upon a time, we had only this strcpy function. Basically, it is a function that copies some bytes, some chars from one source string to the destination string. So you see, you have this prototype with the simple purpose of copying the bytes from the string pointed by source to the buffer pointed by test. A buffer is just a fancy way of calling a space in memory. For example, an array is a buffer, a temporary space in memory, okay? Basically, my destination is at the computer level a buffer, namely a space in memory, namely an array that has a specific size, right? A specific number of bytes. As well as my source string. It is just an array, it is just a string, it is just some space in memory. What is the trick here? What is the thing that can go wrong? Well, if you have a source, if you have a buffer source that is bigger than the destination source, you get something really tricky, which is called buffer overflow. It's very easy to understand. If you have an array of 1000 elements that has to be poured inside an array that is only 100 elements, well, you get something that will overflow, right? The concept of buffer overflow is very interesting, and it is the perfect tool for becoming an hacker. So I will link this video from Computer File, which is very well done, and that explains very well what is going on with this issue. So when we call the string copy function, the programmer must take care the bytes that are being copied don't overrun the space available in the buffer pointed by destination. Okay, so the string copy function doesn't have any safety parameters. If you give a source which is bigger than dest, well, you get problems. Therefore, we need something to improve this issue of buffer overflow. We had to improve the string copy function. We had this new function, strncpy, that this time takes as an input also n. N is the number of chars that I want to copy from destination to source. So I have kind of a safety check. So basically, we have strncpy is like strcpy, but copies at most n bytes from source to destination. As long as n does not exceed the space allocated in dest, a buffer overrun can never occur. All right. Now, even this function is not perfect for reasons that you will find by yourself, thanks to this article. So long story short, strlcpy was created. Now, let's jump into the code, which is always better to understand theory. Theory by itself is not very useful, right? We check the code so you can understand in the marrow of your bones why we need all these functions to perform the same thing. So here we have the first exercise, which is reproduce the behavior of the strcpy function very easily. And here you have the prototype. So you see, we have a function that returns a string, char star, and it takes as an input a source and a dest. Of course, these two are two buffers that this function doesn't care how big they are. That's why this is not a very good function, strcpy. Let's watch the code. Here I have some key points about the strcpy function. So it will copy the string source to dest, including the terminating null character. It is gonna return the destination string. The function is easily misused with the buffer overflow issue. Basically, if the destination string, if the destination buffer is not big enough, anything can happen. All right, given that, let's watch the code. Here I have my main, which is kind of cumbersome, but it is just to make a fancy check. It is a very easy main function. Let's understand this function together. So I have an array of 256 bytes that I have called source buffer. Indeed, an array can be considered as a buffer, a temporary space in memory. Then I have another array, another buffer that is called destination buffer with the size buffer size. You see here at line 25, I have a define buffer size 200. This is handy because I will change later this size so you can appreciate some buffer overflow stuff. So my test buffer, by now it's 200 bytes. Then I declare a char and then an I. Then I do a for loop for 10 times. What do I do 10 times? Well, I'm going to fill my source buffer with a random string. This is a very fancy way of using the random function. You don't have basically to understand what is going on. If you want, just stop and decipher by yourself. It is going to be a good exercise, but basically that's super easy. I'm going to fill the source buffer with random low character chars until I will stumble upon a sentinel value. In my case, I've used 123. So this is a loop for creating a random string. Then at the end of my source buffer, I'm going to append a 0. This is a classical sentinel value to mark the end of a string. And then I'm going to refresh my I to 0 for the next iteration, right? I need a 0 here to start again at the following iteration to 0. I will clear my source buffer. I will fill with another string. Okay, then I simply print the random string. This is put_s is a function that simply put a string. It's an easier print string. It's more rapid. Then I use the ternary operator, which is another fancy operator that simply says, is the source buffer string empty or not? Namely, is there a value in the first char? If this is a 0, it simply means that the buffer is empty, right? If it has a char in that position, namely some random value, it means that the string is not empty. So you can read the ternary operator like that. Is it something at the first position, namely the position 0 of my buffer array? If this is the case, what do? Well, you print the string and the relative size. So I give as an input the source buffer to this s, and then I'm gonna call the string_length function. Okay, to use this function, you have to include this string.h header file. Very easy. So this line just to say print the string, the source buffer, and the relative size. On the contrary, if source buffer is empty, what do? Well, you're gonna put the string empty string. So this very long expression is just to say, hey, the source buffer is empty or not. If it is empty, just print that is empty. Otherwise, print a string and the relative size. You see, it is very easy if you deconstruct step by step. If you don't know the ternary operator, just look on Stack Overflow. It's super easy, all right? Then what do? Well, I print the size of my destination buffer with this command. That in my first case is 200. Then I call strncpy function, giving as an input my source buffer and my destination buffer. So what is inside my source buffer, namely the random string, will be copied inside my destination buffer. That in this first case is 200 bytes. Fairly long, right? It's very easy that the source buffer will fit inside my destination buffer. The function strncpy, as you know, will return the destination buffer. So I will feed directly the function to the printf function, writing the s for format conversion, right? This s is gonna be the string, the destination buffer string. All right, then what do? I'm gonna clear the destination buffer with all zeros, a very stupid for loop, done 200 times, filling all the positions in my destination buffer with what? With a 0. Super easy. Then I'm gonna do again my printf, this time with my ft string copy. I'm gonna basically do the same operation as before, this time with my ft strcpy. So do you see what I'm doing? I'm calling the string copy function 10 times, as well as my ft string copy. It's just to check if my function works properly, because I don't have the moulinet, so I need some test to do by myself. So this very long for, it's super easy if you read step by step, right? I don't think, it is just long, but it's super easy. I have 2 buffers with a specific size. My destination buffer is initially 200 bytes. My source buffer is 256, just by chance. And then I'm gonna fill the source array with random chars. I don't know how long is gonna be my source string. And then I'm gonna check the string copy original and my ft str copy. Beforehand, I'm gonna run the code so you can appreciate the output, and then we are gonna understand the strcpy function. So as usual, I compile the code, and then we are gonna launch it. So here we have the output of my code. And now we are gonna understand everything, right? So let's start from the first case. I have my random string, which is this one, and age, and so forth. The size of this random string is 7. The destination buffer, as you know, it's 200, so the source perfectly fit inside my destination buffer. Here I have the output of my dest coming from the original function, and here I have the output from my function. You see, it's perfectly the same. Let's check another output. Here I have an empty string, and indeed I have 2 empty strings, both in my dest and in the original function dest. This is a more fancier case. Here I have 110 element string, so it's fairly long. Nonetheless, my destination buffer will still fit this random string, so it will work accordingly. So this is the real function, and this is my function, which is super able to copy all the 110 chars. This is the same for this 20 char string, for this 93, and everything, it's fine, right? You got the point. I have a random string that is going to be copied from the source to the dest. So this is my strcpy function. As you can see, it's very short, it's very easy, and now we're going to understand what is happening. The function takes as an input a pointer to char, a string called dest. Of course, this is the destination buffer that has been converted to a pointer, or better, it has decayed into a pointer to the first element of the array. If you don't understand this point, I'll suggest to you to watch my previous video that I've done explaining what is this pointer decay affair. And of course, I get a pointer to the first element of the source buffer. Perfect. Let's jump into the function code. Here I declare an integer I, and this I takes the value 0. This is the meat of the algorithm. I say while at source, so until I have some value in position pointed by source. What do? This is one-liner, which is tricky, but by now I think you are pretty good if you watch my videos progressively. So you can understand what I just wrote. This is not good practice to pack a lot of information in only one line, but this is cool nonetheless, right? Here I say at dest plus I, which initially, what is I? Well, it is 0. So I say at dest plus 0 in the first iteration, and then I have this postfix increment. So I'm gonna increment I after I've used it, right? So the first operation is at dest plus I. Namely, I'm gonna dereference the first position of my destination array, destination buffer. I assign the value to this position, the value at source, right? With the postfix increment. So first of all, I'm gonna dereference source, and then I'm gonna increase source by 1 with this increment. Now you might say, well, I don't understand this code, it's very cryptic, and you are right, because to understand this you have to understand operators precedence, which is kind of tricky, and you don't have to. It's bad practice, I repeat to you, but here we are to learn, right? Here we are to read real code. So here you have written something like that. You have a source plus plus, so this will be resolved in the source itself, and then very simply I'm gonna dereference source. Okay, so I'm gonna get the value pointed by source. Only after this dereference has happened, well, I get the +1. Okay, with the postfix increment. This is tricky, but this is real stuff. So you need to stumble upon real stuff to get better, right? It's like going to the gym. If you always do the simple ones, you are not gonna grow. So all the time I dereference the pointer src source that at every time is going to increase by 1, right? With this postfix increment. At a certain point, I will dereference the pointer that points to the terminal char 0, and then you have the while that is going to end. Every time I'm going to put the char pointed by source inside dest plus I, that every time is going to increase him as well. So we start from 0, then we go 1, 2, 3, 4, 5. So every time I'm gonna stock inside dest plus I the char which is in source. Spend a little bit of time trying to understand what is going on with these 2 lines. If you decipher step by step, it's super easy. At the end, I'm gonna return dest, and that's why I've used the I to increment my dest. On the contrary, I've used the pointer arithmetic to increase my source, because I don't need anymore my source at the end of the function, right? I can discard this value. On the contrary, I need dest. Therefore, I've used this I, and I haven't increased the destination pointer value itself, because at this level, I needed this return value. Okay? And as you saw, it works perfectly with an empty string and with a filled string source. Okay, now let's change a little bit the code and let's try to understand better the program. Now, before we add the string of 110 chars, so we're gonna do 111 buffer size this time on this code. I compile, and as usual, I'm gonna run. You see, it works. Let's see, I have my 110 random string that perfectly fit inside my destination buffer of 111. As you can see, the original one and my function. Perfect. Now we are gonna change the destination buffer to 110, and let's see what is going to happen. I compile and then I run the code. You see here, I got a problem. I get this time that this random string of 110 elements is not fitting inside my destination buffer of 110 bytes. Why? Well, because I need 1 byte more for the terminating character \0. So my destination buffer is not big enough, and this produced an error. The function indeed specifies that if the destination of a string copy is not large enough, then anything might happen. Indeed, a mistake. And the string copy function doesn't have any form of safety. You see, this is a black box that takes a source buffer and takes a destination buffer. It doesn't have a clue how big this destination buffer is, and it cannot know because when you pass an array to a function, it's going to decay to a pointer. Again, the argument of array decaying, see my previous video to understand better. So that's it for this strcpy. All the responsibility is on you. You have to know how big is the destination buffer or anything might happen. Okay, now we're going to watch another function. This time is strncpy. So we have some safety guard here, but let's try to understand better what is going on with this function. In this case, I have to copy n char from source to dest. So I have one argument more. If n is major than source, I will pad n minus source of 0 into dest. Confusing. Pretend I haven't read this line by now. The last is return a pointer to dest, essentially like strcpy. Here you have two important points. String copy is not intended to be used as a safer strcpy. It is supposed to be used to insert one string in the middle of one other. That's why not \0 is added. If there is null bytes among the first n bytes of source, the string placed in dest will not be null terminated. How confusing is this stuff? I totally understand you, don't worry. So we are gonna read these lines after the code. It is gonna be easier. So here I have my main. Look how big it is. I have toDefine at the top and my main with all the stuff just to make a good output so you can understand perfectly what I am doing. Let's just briefly overview. Basically, this is equal to the code of before. It is, I make the test with the original function and my function to understand if I did everything correct. And for you to understand very well what is going on. So first of all, I want to run this code and then we are gonna understand line by line. So this is the output of my function. And we're gonna start from the very top, okay? I don't know, how many ones do I have? A lot. Okay, we start from here. Here I have the rule. Basically, if n is major than source, namely if the number of chars that I want to copy are major than source, I will pad with x0's destination. Now we're going to see what the fuck this line means. So I have my source buffer, which is this random string, right? That has len 7. I have created this source buffer like before with the random function. Destination buffer before function is this big boy here. Is this big boy here that I filled with all slashes so you can very well see what is going on. And this buffer has len 60. I have decided that this buffer has to be 60. And in the first case is gonna be 50. So I wanna copy 50 chars from this random source. You see, the source is less than the number of chars that I wanna copy. And you see this condition if n is major than source, exactly like in this case. N is major than source. I have 50 and the source, the random source, is only 7. So here I call the function strncpy, and this is the destination string. But what I want to see here is the destination buffer. It should look like something like that. I have my string, which has been copied, and then I have all these zeros. What the fuck are these old zeros? Here you see I have if n is major than source, I will pad with 43 zeros the destination. That's why here I have 7 chars coming from source, and then I have 43 zeros. And then I have my buffer, the rest of the buffer. That is exactly like it was, okay? You see, this is the real function, and this is my function. And the destination buffer is always the same. Let's watch another example. This is an empty line. I get my source buffer. This time that is an empty line, namely length 0. But I want to copy 50 chars from this empty line. What is going to happen? Well, you understood. I have to pad with 50 zeros the destination buffer. Tricky, right? Here I have a longer, the one of before, 110 chars source. I want to copy 50 chars from source. What is going to happen here in your opinion? I'm going to copy indeed 50 chars from the random source buffer, and then nothing. I have just taken 50 chars from the source string and put inside the destination buffer. That's it. That's the order. I have 50 chars which are not, pay attention here, null terminated, and basically that's it. You see, these slashes just represent the destination buffer reminder. And here, of course, I have my function that it is exactly the same, right? It works the same. I have the destination buffer that is exactly the same. So do you understand how this function works? I just want to take n chars from source. I don't really care if source is bigger or less than n. I will just take n chars. If they are not inside my source, I will pad with 0 dest. It's kind of tricky, this function, in my opinion. Let's watch the last case just to make sure we understood. We have this random string. I want to take 50 chars from this. There are not 50 chars inside this source, so I'm going to do 50 minus 20. I get 30 zeros that I will pad in my dest. And I get here, of course, my 20 chars, the ones that I can take from source. The cool of this function is that when I have a source that is bigger than my destination buffer, in this case I have a destination buffer of 60, but I have this n that is going to be like a safeguard, right? Here I say I just want 50 chars. I just want 50 chars to put inside my destination. I don't really care how big is my source string. You see, I'm gonna print my 50 chars. I don't have the final \0, and that I lose information because I'm gonna truncate the string. That's the function strncpy. So here we are with the strncpy function. As you can see, it's short, but it is trickier than the one before. See, this time I have a third input value, which is n, namely the number of chars I want to copy from source. Here is my routine of the copying between the source and dest. The function per se is very similar to the string copy function. We have only this and this time that we have to take care of. And where I say if at source, namely you perfectly understand if the value pointed by source is everything but 0, and this time we have an and, logic and, n, namely n is major than 0. If this is true, namely if this and this are true because we have an and, all the expressions have to be true. What do? Well, we are gonna dereference dest plus I, like before, and we're gonna put inside this address what is inside at source. Very easy, right? You put the value pointed by source inside at dest plus I in the first case is 0. Then with the postfix increment, I'm gonna increment both I and both source. So here I have an increment directly of the pointer, and here I have an increment of the pointer which is indirect through the I variable, because at the end of the function I have to return my dest. It's exactly like the previous function, this strcpy function. Then in this case the difference is that I have to decrease n. I have to decrease n because I want to copy n chars. Therefore, this is a very important value here that I have to take care of. With this while, simply I say until I have a char and until I still have to copy some chars, I will do that. I will copy the char pointed by source to dest. Then I will decrease the number of chars that I have to copy. This loop will continue until I have a char and I have to copy a char. Okay, that's very easy. Spend your time here, but that's easy. Then here I say if n minus minus. So I say, practically speaking, if n, namely, do I still have some chars that I have to copy? Haven't I exhausted all the n's inside this while loop? If this is the case, what do? Well, you're gonna copy inside destination plus I, with I this time. Where is I? Well, he is exactly in the right position because here I have I plus plus. So I, in this case, is already in the correct spot where I want to pad all my zeros. So I say at dest plus I, put 0, and then you just increment I with a postfix increment, and I decrement n as well. Then I simply return dest. I know that all these postfix increment, prefix increment, dereference can be tricky, but by now you should learn very well how these commands work because it's useful. So maybe it's difficult now, but it won't be. Once you understand, it's super easy. So here you have all your algorithm. This time with this n that is gonna control how many chars you want to copy from source to dest. So in my main that we haven't yet checked, but you saw the output and it's very easy. I have my n and I have my destination buffer size, which is 60. Let's try to do something here. I'm gonna change the number of chars that I wanna copy to 70. So I have a destination buffer of 60, but I wanna copy 70 chars. What is gonna happen? You see, we have a mistake. strncpy will always overflow, of course. Destination buffer has size 60, but size argument is 70. You see? Will always overflow. This is for sure. So here with these two input values, I can really be sure that I won't overflow. Like in this case, I say I want to copy 59 chars. I don't really care how big is the source. I just want 59 chars to my buffer size that is 60, my destination buffer, of course. Let's run this code again. You see, this time it works very well, very properly all the time because I have this n which is 59 and I don't really care how big is the source. I will always copy my 59 characters if there are in my source. Now I want to check with you the string that has a lot of chars, the one who is very big. You see here I have my usual string of 110 elements. Here I say I want to copy only 59. Here I have my string with 59 chars, but I don't have this time the \0. It hasn't been appended to this string because I want only 59 chars, and in this first 59 chars there is not \0, so it is not gonna be copied, appended by the function itself. That's why this is not totally correct to say I have a buffer of 60, so I need 59. I can use here 60 itself, okay? And it still works because this time I don't have to append nothing. I just want to copy 60 chars from source to a 60 char buffer destination. Now I think we are ready to understand better what is going on with this strcpy function. So this is not intended to be a safer version of strcpy. It is just supposed to insert one string in the middle of one other. This is the big idea, the big point of this function. That's why a \0 is not added. Read here, if there is no null bytes among the first n bytes of source, the string placed in dest will not be null terminated. You just saw that. Here is just another twist of this theory that you can read. I will push this code on GitHub if you want to understand better what is going on. But basically here you have your string n function. The main is cumbersome. If you want to understand better, of course, maybe you can screen or watch on GitHub. But it is just to understand very well what is going on, because I think these two functions are not very easy if you want to understand them very well, right? The code itself is very easy. It's a very short function. But to understand very well what is going on, you need to spend a little bit of time. Now we're gonna check the last function, which is this one, strlcpy. Finally, we're gonna finish with this strcpy stuff, which is kind of super boring, I think. This function is allegedly the safest one, but let's read the theory behind, right? This L in strlcpy means the length of source. So this function is going to return the length of source. If this len is major than destination size, the output string has been truncated. Okay, so this function will always zero terminate the destination string. Again, let's watch the code so we can understand better what is going on with this function. Basically, the main is always the same. I use my function and the original one to understand if I did everything correctly. Okay, so first of all, we're gonna run this code. Okay, this is the output of this strlcpy, and we are gonna check some strings. So as usual, we have this random string that has len 7. My destination buffer this time is 100 bytes, and the len of the source is 7. This is the return value from the function, because this function is returning the len of the source. So this is the destination buffer after the original function, and this is the buffer bytes that you can very well see. I have my string that is copied and a 0 at the bottom. Perfect, very easy. Now we are going to check a case where we have to copy more chars than the destination of the buffer. This very long string, which is 110 elements this time. The destination of my buffer is 100, but the len of the source buffer is 110. Okay, so what is going to happen? Well, I have my string here. That's very well done. But this time I have a \0 at the bottom of my string. So I have truncation and I have an addition of the \0. So every time I know that my destination buffer has this terminating character. Every time I have truncation of the string if this is bigger than my destination. And basically I'm always sure that I have a string that terminates, not like str and copy, that it just takes n chars and stock inside destination. It is qualitatively different, right? I always have a 0 at the bottom. Okay, that's true, I lose information, but I'm sure that I don't have any overflow. So let's go to watch the code of this function. Here, as usual, I have my main function that you can check on GitHub, but it's easy, it's kind of long just to give you that beautiful, understandable output. And this is the strcpy function. As usual, it takes 3 inputs. And this time I declare a variable len. Initially it's equal to 0. Then I say while at source plus len at position 0 of my source, and minus minus size. This is a prefix minus minus, right? So it's immediately size minus 1. So why did I have to use this prefix minus minus size? Well, size is the size indeed of the destination buffer. So simply I say if there is still space in my destination. So if I have a size of 100 bytes of my destination, I want to make this loop 99 times. And this minus minus sign is going to allow me to have this property, right? I have basically size minus 1 while loops. So this is a pro way of understanding this problem. So this is not good practice. It is not readable, but my friend, you need to really push to understand you cannot really continue with easy code. Just push a little bit, become very good at this stuff, and then just write very easy, intelligible code for the world. But by now, just go a little deeper. Okay. At least this helped me to really overcome my weak points. If you do all the time simple stuff, it's gonna be very tricky. So here I say minus minus size. You understood that if you have a size of 100 bytes, this is gonna allow me a loop of 99 times. Perfect, that's what I want because I need a spot for the \0. Here I say at source plus len is initially 0, so I say if at source plus len in position 0 of my source I have some value which is not 0, and I still have loops to do, I still have a size. What do? You just put inside what is at dest the value which is at position source plus len, which initially is 0, that then you're gonna increase by 1. So take the value position source plus len as stock inside at position dest. Then increase both dest and both len. You do this until you have a value at source and you still have the size value. At the end, you're gonna pad a dest with a 0. Dest is in the right position because I have this plus plus, namely this dest this time is incremented itself. I have a pointer that has been incremented, so it is in the right spot. And then I do this while loop that it's tricky because it simply says while at source plus len. Do you remember the len of before? Here it comes. Here there is written until you have something at source plus len. So until you still have some values inside my source, what do? Well, you just increase len, namely you go on in your source and you find out how long this source is. Because we have to return this value. This function returns the length of the source. So that's it. This is the strlcpy. This is a function that is gonna copy what is inside source to dest. It's gonna do this copy at maximum the size -1 of dest. This size, this parameter is very important for this function. Okay, so let's check again the output of the function. Here all the time I have the len of the source buffer, which is in this case is 0 because I have an empty string. Let's take this random string, which is 78. The size of destination buffer is 100. This is the value returned by the strcpy function itself. And then basically I have my 78 shards copy into the buffer very easily because it is bigger, so no problem. Now let's change the destination buffer to a ridiculously low volume, like 10. We have a 10 destination buffer, very short. We're gonna run the code. You see, no problem at all. I have, for example, this random string, which is already bigger than the buffer, but I copy the source into dest 9 times, right? Size -1. So I have my 9 shards inside my destination, and then I have a 0 padded at the bottom of my string. So this is a very safe function to copy one string into another. Of course, this is not perfect because I have truncation, even in this case. So long story short, that's all a mess with this string copy function. It is the responsibility of the programmer to do this thing properly. Okay, that's it for this very long video, and if you understood everything, congrats. Yeah, that's it. Kind of boring, right? I don't want to do this anymore. I won't do any more these boring videos. Too boring. Okay, thank you for watching. Bye, my friend.